Hello, my name is Paul Falcão. This is a seminar about doing ray marching in Material Maker. This is the program, Material Maker. I will now explain where is the program, how can you download the program, so you can follow me this seminar and do some exercises and play with the program. So to download this program, Material Maker, you go to search for Material Maker in the web. Material Maker. Okay. And there are two links. One, the first link, it's the official web page where you can see the materials. So this is a program to create materials, PBR materials, so materials that have the metal component, the albedo component, every component that you normally use. The program, his main objective is to create textures using nodes, similar to other commercial available programs like Substance Designer and others, but this one is free. It's made by a person called Rodolph, also known as Rodzilla. I think he is now in also seeing this presentation. Hi. And I will talk first about the program, what can you do in the program, explain the basic concepts of the program, how you can do 2D stuff, that what the program was originally made for. And then I will start explaining how you can also use this exactly same program to do ray marching, because the program is very generic, the way it works, and you can make your own nodes. And because of that, I made a library, which is basically a JSON file that you download from the GitHub. And put the file there and load the file, and a bunch of new ray marching nodes will appear in the program. So this is the main page of the program. You can go to this web page to download it. You can download here the program, install the program, the normal stuff. It's a small program. It's not like Unreal or something like that where you have to wait hours to compile something. It's very fast. Also, another very interesting thing is that the program is entirely made in Godot. And for those who don't know it, Godot is a freeware, open source engine, 3D engine, but you can also do many interesting stuffs in Godot, also apps like this one, Material Maker. I will not download it now because I already have the program. It's a free open source program, the Material Maker, that is made in an open source engine. Okay. Let's see, material. It's also, you can also browse his code here. You can also download the latest version in GitHub. Okay, if you want to download the very last version, you can go here to dev desktop builds, and you can download the last version. But for now, you only need the version 0.97. Okay, so after you download the program and install the program, basically you will have a folder like this one, and you double click on the executable file, and it's fast to load, and the program is already here. So what do you need now? What do we need now? These here are the nodes. that come built in the program. In this folder with my name, it's the new nodes that do ray marching. To add these nodes, you first need, like I said before, to go to my GitHub page. You can search for my name, for example, and Git, or put Material Maker Ray Marching, and something I think like this will appear automatically. Let me see if it works. Yeah, it's the first link. Material Maker Ray Marching. This is the file you have to download. Here I also explain what I have already said. Download Material Maker, install, download this file. So you download this JSON file, which is now uploaded about 1 hour or 2 ago. This 0.03 file. And the way you can install this new nodes is by going this here. Okay, I will pause here because it's probably not very obvious. You have to click here, Manage Libraries, and you can do Load Library, and you select where you put the file and download the file. I actually don't know. I think I have probably loaded somewhere, but you download, open, and these nodes appear here. So this library has a lot of nodes. I will not right now talk about them. I will just explain now how we can play with the program. So like I said, this is a material, it's made to make materials. I just drag here one of the panels, so I would have more screen space. And so this is it starts with this node to do PBR materials, which stands for physically based materials. And we can start here and, for example, drag a star, okay, and click here, preview 2D, and the star is here, okay. And you can change the parameters here, for example, like a normal node, okay. And what you can drag another node, and now you see a circle, and you can combine the two, doing like, I think it's blend or no, blend, yeah, opacity. For example, and do whatever you like to do. Let me see here another example. I have another thing that you can do, which is very useful, is instead of dragging the nodes, you can click on the output. So these are the input nodes, and this is the output. You can click here, drag, and it will show you the nodes that are compatible with this node. For example, brightness and contrast. Okay. Okay, for example. Or after this, I will do some colorization. A very cool node here, and you can, for example, do this. Put another one here, for example, yellow or something like that. Okay. And it's okay. You are doing now. The important thing to understand now is that these kind of programs that use nodes, typically you are passing data from one node to another. In this one, you are not doing that. You are actually building a GLSL function. So this is a function. You are building a function using nodes, and this function can be copy-paste, for example, into shadertoy. So I can, like I said before, drag here, add the node debug, click show shader, and this is the generated shader. Okay? It's more or less understandable. You can copy this shader, go to shadertoy. Let me close here some panels. Okay, let's go to shadertoy. I don't know if I have my internet. Yeah. Create a new shader. And just replace. Click play, and here it is. Okay? This was the shader that we procedurally generated here, just using nodes. And this is more or less understandable. For example, I'm seeing here the radius. For example, I can go here, do something like scene time, I think it's that. Compile. Nope. Something. Oh, is this constant? Nope. Global variables. Yeah. So probably. But we don't need to change the. I would like to animate this, right? So instead of doing the things here, I will use this error to show another way of doing it. You can go here, for example, and use, let's say we have here, oh, this is the number of, okay, this is the size, okay? We have a special variable called $time, okay? And we use the normal math functions to control here the value. So we use the sine function that goes from -1 to 1. We multiply the sine function by 0.5 and we add 0.5. This way the sine function goes from 0 to 1, but I want it to go from let's say 4 to 6. So I will just multiply by 2, and this way 5 less 1 and 4 to 6 is just 1. Yeah, so it should work. And you can see here it's moving slow, so we accelerate the time, multiply by like 32. Too fast. Let's put like this one. Yeah, we have an animated shader. Again, show shader, copy the shader here, press play, and you have a shader. You can publish the shader already. A shader made in Material Maker. So another more interesting things about this program. By far, for me, one of the most important things, well, this one about creating functions was very important, but now it's a more geek stuff, but the way the program works is actually each one of these inputs, it's actually calling a function, okay? So this allows us to do many complex things like ray marching and many complex things, because you are not passing data from one node to another, okay? You are actually running a function. So this is a function, and this function has a function input, and this function has a function input, and something like that. So this function can be called, if necessary, by this node multiple times. That's what happens in the ray marching node. Another very cool feature is that you press Ctrl W. I will say it again. Ctrl W is also here. Edit. No, I don't know where is the shortcut for that, but it's Ctrl W, and this appears. This little pencil. You press the pencil, And now you have an editor for the node. You can completely edit the node. So this is a special node because it's just a gradient. You can add parameters here. When I say apply, the parameter is added here. You can control all the code. Okay. For example, I will just make some things for you to understand. Let's create something called value. Okay. This is the display. This is the variable. And this is the outputs, okay? This is a special function because it's a gradient, and now it outputs RGBA color, okay? So I will now multiply the color. I have to just first get just the RGB and then multiply this by this new value that I created there. I put the $sign there, and the alpha value can be just 1.0. Click apply, and then we have now modified the node. See, it's very, very powerful, very simple. For example, now it's switching between, it's not 0. With 0.1 precision. You can go here. I don't like 0.1 precision. I like a lot of precision, so I will just add some zeros here. Click apply, okay, and now you have more precision. And of course you can animate this. You can just put, again, let's just copy this and multiply by a different, yeah. So we are animating. So I think it makes a good blend between code, if you want to, and a node-based approach. I like this kind of approach because I used to do remarching by code, and I also do it, of course, in shadertoy and much before that. And you spend a lot of time doing the boilerplate, right? Setting up the remarcher and stuff like that. And sometimes you are not interested in that. You just want to tweak something, create some special function, investigate something new, and you can use this program and program here directly and just play with that, okay? Or if you want to, you can go to shadertoy, for example, play with the code there, copy paste here, because the code is GLSL. Here is just a very small line of code, but you have the main code, which actually I don't use very often. The instance functions and global functions that would require me another session almost just to explain this. But basically, these instance functions are functions that are instantiated, are created one instance for each instance of the node. Okay, so this node has one function. If I do another one of this, for example, which I did the normal copy paste. By the way, every node has a preview node if you click, and you can also click here. I think it's there, or I don't know. Okay. You can also set always an output using it's a new feature called, if you press Control and press the output, it creates a lock. And then if I click the other, I delete my own node. Okay, it's an unimplemented feature. You don't have undo, okay? So you have to live with that. So I lost my node. Yeah, no problem. I can drag another node here, no problem. Yeah, now it's the original shape without, but I think it's just I just did that. Yeah. So no undo. Be careful. Save often. I was showing about The shape, brightness and contrast, colorize. The code. Yeah, the different. What can you do with different tabs of the code? I will just show you a much more complex example. Go here to my notes. For example, I will not dive into it, but this is a node that creates a fox. I will talk about that later. But I have a global function here, for example, which, by the way, just out of curiosity, this is a neural function, a neural network. It's a neural network that generates a sign distance function. Okay, well, I basically use a model available on the net by Ida Faber, and I use a tutorial that explain how you can convert a model into this code, and is done by Blackhole. The YouTube is very good. You have to see it. So, but just to show here that you can have much more complex functions, and yeah, it's very cool. And also, I think the developer is implementing. Yeah, you can now. Yeah, but it's still not perfect because I deleted this and I put again and still shows you the error. But yeah, the idea is to have a full. The editor shows you the errors and the normal stuff. Okay. By the way, if you want to create new nodes, I strongly advise you to download the Godot and open the Git, the original source. It's very easy. Just open, double click, and it will run. It's no extra work almost, and you have much better quality. You can debug much better because it opens a black box with the errors, with the compile errors, and here you don't have that box. So sometimes it's hard to know which error, what is the error and the line of the error. You have an error in your GLSL code. So this is the 2D stuff and how you can play with this program. So what is this node? This is the node where you generate the. I will just remove the time, so I have a fixed. This will not move, and here also. Yeah, or 0.1. No, 0. I can drag, of course. Okay, you can. This is because this is a shader. It has infinite resolution. Okay, it's not again. This is not manipulating a bitmap file. Like I generate a bitmap file here, and then the bitmap file goes to here. No, it's not doing that. It's generating a function, a shader that runs per pixel. Okay. So I have now here an image, and I would like to apply this image to this to create a material. Imagine you can click the preview 3D, and this is what the program is originally made for, to create textures. So you can create, you can use the normal, in this case is the PBR metallic workflow, because you have metallic and roughness. Yeah, so I can, for example, use this to here, and let me see them. Yeah, so for example, now I can also of course select and drag. So now I create a texture, okay, where I use the same shape, okay, to define how much bright, how much clean the surface is, okay. and there is no brightness in the shape, and it's here. Okay, it's if you are familiar with the other programs, it's the same. You can also load your model. You can also paint the model here. I don't know that part of the program, so I will not show that. But yeah, you all have also here to change so it multiplies this with this value with the function and the values that came from here, and then you can go here, file, export, and export to the most used programs. Okay, this was the node that existed before. Now you have more nodes. We have, for example, one very interesting, which is the dynamic PBR material, and basically you can use time, so it becomes an animated material. Okay, and you can after that export that, for example, to Godot, and you have an animated material there. Okay, not just a texture. Okay. And you have also here another interesting thing, which is a remarching material, which is something new. It basically uses a technique. What is this? This is here we are drawing a cube, but we are drawing a cube. We will draw the cube and run array marching to paint the surfaces. And because we know when you look at the cube where we are and where the point we are looking at and stuff like that, we can do the calculations and simulate something inside the cube. So we will put things here that don't actually exist in reality. They are not made of polygons, so the polygons are just these ones from the cube. I will just again use this function drag. You drag here and you put, for example, a torus, and here is a torus, and you can, if I change the size, see, this happens because you are actually looking at the cube. You are not okay, you understand? You are just drawing in a very special way the surfaces of the cube. So you can do a whole game using just this technique. Okay, putting just cubes in the game and procedurally making the game. Okay, it can be animated, of course. Now you have here the albedo or color, the metallic. You can drag here and use. So this node, we are now already talking about ray marching. This node torus is one of the ones that came out of the box with the program. If you go, let me browse, because I think when you install it's something like this. You have this 3D, and after that you have SDFs. It stands for sign distance functions, and you have all these SDS. And you have, for example, here a sphere. You can change for the sphere, yeah. And you can, of course, combine these two objects using a Boolean operation. Yeah. And yeah, you are combining now the two objects. You can, for example, animate this one. I want to translate. Again, I drag because if you drag, you only will see the nodes that are compatible with this node. I start writing translate. Put here. Yeah. And I have, for example, okay, it's this one. I can, of course, animate this again with the sign distance function. And you have here, let's speed this up. Yeah, too much fast. So this is a way to, you can also define the color. And here, to define the color, you define the color using the equivalent of a 3D texture, but it's not a texture or a volume of data. It's actually a function that defines a color for each point in space. It's called a text 3D. This is, for example, let me just use one of the standard ones instead of mine. Texture, yeah, for example, is this one. Yeah. So this is the texture. Let me slow down this. So here you see that the whole object uses the same function. So when the ball goes up and down, the texture is dynamically changed because the ball is changing the position, right? So if we want don't have this this behavior, we will have to use another function that I released today. I will talk about that later. And we can also add metallic here, for example. Let me just use, this actually is one of my nodes. Does not. And this node, if you use this node, you will be able to export this shader and use this shader in Godot or in other engines. Okay, but to do my shaders, I use my own nodes, so I will not use this. I can leave like this or not, static. I will close this just to save screen space. I will click now in preview. Now you have two previews. You can set one output to one and another output to another. So to do ray marching, I use my own nodes, and I have made some nodes that what they do is they render the objects. So this is one of the first nodes I have made. So to do this, you just drag here, and automatically you have a shader. You can already put this shader in shadertoy. So it's very easy. Okay, and this is a very basic node that has you can do two objects here. Normally this is is predefined here. If I show you the code, so these are the inputs. So I have predefined a sphere and have predefined a floor using math. Okay, but the idea is to replace. So you can drag here and here. You can, of course, use again the time variable to, for example, rotate around the camera. Let's say something like this. Probably too fast. I don't want you guys to have your head spinning. Yeah. So, yeah, time. Let's do another sign of time. Sign of the sign. So as you can see, you can, if you like to code, you can code. If you like just to drag nodes and don't care about coding, you can also do that. Of course, if you know how to program, it's better. Yeah, so this time I can something like slow down his sync here 0.5 just to create some smooth slow animation so it can work. So you don't have, because this is a material maker program, you don't have a timeline. Okay, so one of the questions you could ask. Oh, I was not expecting this. Why is like this? This is strange. It was not supposed to be like this. It would supposedly maintain the aspect ratio, but I have to check that. Probably an update, I don't know. Strange. Let's leave it like this. And we can start now creating our shapes. So you, for example, put a torus here. And from whatever reason it's not working. So I will just start everything again. I don't know. Oh, that was something was not compiling. Probably my function was not correct. I don't care about it. Let's forget about that movement. Or just make a very slow one that I know that works. I don't. Actually, I can double click. I don't. Oh, this. You can use the left, the right mouse button to have a better editor. So times again 0, 1. Let's just stick with the basics. Okay, something like that. Yeah, we are on top of the object. So let's multiply here the distance by 2. So now we will drag here, put a torus. We can specify the axis of the torus. For example, this. Okay. The normal stuff. Okay. And now you can let's go here, add a different type of object, for example another torus, and you can specify a special type of union, which is I think it's called, nope, I don't remember the name. Oh, it's here, smooth boolean. Okay, drag here, yeah. So this you can see here that now we have this very, if you know about this sign distance things, you can smooth it because this is a function. By the way, some of them they have, let me just show you something. You can press again control here and it will lock the preview here, and I can click here, for example, put the second preview here. I'm doing stuff that I don't normally do. How do I put something here? Well, I would like you to show that when you press, let me unclick here. If you can also use this. I would like to have a window where this was showing and another window where the preview was being shown. Okay, I think I can drag this to another place, but yeah, no, whoops. Yeah, this can also be like this. Okay, and I can do use, I think it's shift, and now this, yeah. So this is the first time I've actually done this, so yeah, but it's cool because you can use these sliders. So these sliders, again, these are not, this is very interesting because these are just nodes, normal nodes, so there is no magic here. The controls you are seeing is because you pick here a radius, okay? But it's just code. So this whole torus is just this function, okay? This just these functions here. Yeah. So another thing that you can do is add a texture. Let's add in the library here, for example, again a 3D texture. For example, this pattern. Add this pattern here. Yeah. So you have this pattern here. You can again specify things and add, for example, multiply, sine. Okay. Can play with this. This is one of the render nodes, but you have more nodes. This was the first node that I made. You can just change the render and pick a different one. This is a more advanced one that I've made, which is better actually. I should have used this one initially. This don't have the movement. I will just add here the movement. It's now cosine. Okay. Now you have a lot of more parameters here. You can choose where you are looking, the camera zoom, camera distance, like the FOV, the how much this is not physically based, okay? So of course you can add a different specular here. Okay. Play with this, and again this is a shader just to show you. Go debug, show shader, go to here to shadertoy, replace, yeah, and you have here the shader, and you have made a pretty shader. Just dragging some nodes. I don't know if I'm talking too fast or too slow. No comments here, so it must be okay. Yeah. You have to create. You can't import shapes because shapes are normally made with polygons, and here you are not. So if I don't, for the people that are listening, the question was if we can import shapes here. The direct answer is no. You can't import shapes. So you have to procedurally create a function that generates that shape. But there are now some possibilities using a neural network, for example, to generate procedurally a function using sines and cosines that will generate the object. So the input is it's the 3D polygons, and the output is a function. I will show you here one of the examples. If you go here, for example, I have here a bunny, again made by Blackhole, and I can put here the bunny, and now you have a bunny here. Okay, and of course nobody programs. It could be done, but nobody. The bunnies with too much reflection, and I don't like the texture. And I think it's not. Let me rotate. So, for example, one simple question: I want to rotate this. What can I do to rotate? So I drag. We must change the object. So we add a rotation node, and put here. And now we can rotate the node. We have two bunny. It's a torus. Okay, I understand. We were blending the bunny with the torus. yeah, everything works. We can put multiple bunnies wherever we want. Yeah, but this method it's still in early stages, let's say like that, and it works okay for this kind of blobby organical things, but if you have a lot of data, you will have a lot of data in the shader, so it doesn't scale very well. Okay, these values were generated by the neural network. Okay. This one was not made by me. I then, like I said before, used the Blackhole Python code to generate a fox, which is something more or less similar. Okay. Blending the two. Oh, animating the fox, yeah. So again, there are no. You can do that again just procedurally. So apply some distortion to the legs, which will not look okay. So if you want to use this program to replace something like Blender, you will be disappointed. It's not for that. I use this program much more for something like many years ago. There was a program to do ray tracing. I don't actually the POV POV ray is more like that, to do procedural things. Okay. Not for doing very complex things that you can already do in a program like Blender. Because this also doesn't scale very well, because if you put a lot of nodes, you will have the output will be a very complex function, a very complex shader function that runs every pixel. So if you want to do a game using this kind of techniques, you need to do something more smart. Bake into voxels, or subdivide the space into many different functions, smaller ones, and combine them and stuff like that. Okay. Here it's more about having fun, doing stuff, and creating pretty things. Sorry? Yeah, so this node is a node that rotates the previous nodes. Mm-hmm. If you combine this shape with another shape, this rotate will rotate all the previous things. Oh, yeah, you can, you can, this is, you can, for example, these two, select and press Ctrl G, and it will create a group. Okay? And This group is also very, you can, for example, I want to expose this parameter, so you can click here. Yeah, thanks for this question, because I was not talking about this, thanks. And you can say a name like rotation. Okay, and this is a fox, rotated fox. Yeah, go up, and now you have a rotated fox, which you can, yeah, so it's composable. Yeah, you can do, of course, that's a thing that all the node-based programs have, and of course this one also has. So you don't need to write code to do this. It's just composing nodes is something you can do visually. Yeah. So another thing that you can do with this node, it's so this here is the second object. We will not play with that. Let me just delete this, and we will add now. We can add, for example, let me see, an HDR file, 360 file that you. There are some very cool files in, I think it's Heaven, something like that. Yeah. Oh, it's not called Polyheaven, and they have very good images. You can download them from here. This is just one of them. You can drag this here, and now you have a very beautiful sky here. The problem is that it will not export, of course, to shadertoy now, because you are loading an image. So, but because of that, I've made some procedural ones. There is one built in, a very ugly one. This is built in the node, and you can also. But I added some here. I think is yeah. So this one, I did go to shadertoy and look for some of the codes there, and this guy did some nice one, and you can also add more here. So you can, so this pre-bakes the before. If you do something like this, you can see how it works. Is actually this is the code, and it uses a buffer. You can also use images, okay, like I'm using here, okay. So, and you can, at the middle of these steps, you can bake the output to an image and blur the image. So you can combine the two workflows: the functional workflow where you create a function, and the typical have an image, blur the image, and apply the effects on a bitmap file. Okay, you can still use that. So let's use this texture here. Yeah, and now we have a more pretty image. Yeah, so now I'm more or less going through the development of my nodes. So this node has a big limitation, because as you can see, you can only put two objects, okay. And in the last few weeks, I've been working in a way to combine and have infinite objects, okay. A way to combine many objects. I call that multi-field sign distance functions. I will talk just briefly about it. I will now show my shadertoy about that. Let me see if I uploaded like 2 hours before. Let's search, browse. It's a shader that shows an image. Okay, this is very slow. Let me just for my shaders. Yeah, my very old shaders, like 10 years ago or more like that. Yeah, so this is the new shader. This, by the way, what you were seeing there was there is a, let me, so this Chrome does not use my integrated card, and this one uses my GPU, so it's much faster in this one. I have predefined this way because I don't want to use the GPU in the other. Yeah, so this is all done manually, and I have explained here what is this function, how does this works, and this was not made using Material Maker, but you can do it using Material Maker. In the last few weeks I've been developing this technique, and here I put all the details about it, where the things that I read about materials and shaders, and about 20 years ago I did some path tracing, but now I had to update my knowledge to the current stuff that people are doing. 20 years ago I did path tracing, but it was very basic. But it was already path tracing in the time that no other commercial available program did it. Only very specialized programs out there had that functionality. So this is a path tracer node, like many others that are out there. It's not very correct, so the idea it's not to show how to do path tracing, it's just how to show this technique. And how does this technique work? So the technique works by it's basically a function. Normally in a sign distance function you specify the three values in space, and it returns a value, the distance to your object. In this function, you are not only defining the objects, you are also defined for all these parameters, the metallic, specular, roughness, everything that you want. This is I propose, and each one of them has an ID, and you pass the field type. So the fourth parameter is the field type, and the output is the output of that field type, and also it also returns the sign distance function. So this way you can combine all the data about your scene, about all the objects in a single function. It's a heavy one, it's true, but it's very useful for programs like Material Maker, this kind of approach. It's also specify a standard way to define objects. I do a lot of research about it, and I propose this order of fields, and with this you can basically do almost anything, but you can also specify your own fields. I suggest to use the 999 as the table ID. More things. Yeah. So we will use this kind of approach into now here in Material Maker. I will show now the nodes. Where is the delete? Oh, here is the delete. So these nodes are here, render. So it's Material Mate is on MFSDF, multi-field sign distance functions. So almost all these nodes I made in the last days, and this is the node it only has one input. Okay. And how does it work? You drag here, and the third is it has more boilerplate, because you have first to specify the object maker. First you do an object maker that have all these properties. These properties then are mapped into that function that I was talking about. And also, by the way, this was made in a hurry, so this node is not very perfect. I will update this in the next release. So, for example, metallic does not work, and most of these parameters don't work. The parameters that work are, for example, specular, and this one also, and let the object. And yeah, so but it's not I leave the parameters here. Why? Because this is just a render. You can do your own render here in render. For example, I also made a path tracing render that I will show later, so you can use exactly the same tree here and render it in a completely different way. And your render, for example, this is just the basic one, because I have one here which is advanced, who has a lot more parameters. It has all the other parameters there. So the idea is to support transmission and other every other things. So the big improvement here is that you can now combine how much all the things that you need. Here you have the object. You can, for example, change here the object. Okay. Put the axis here. Change the color. Okay. And now I will not change here the properties of the object. I'm changing here the properties of the object. Okay. And if I can now combine. Let's create another object here. For example, a box. Let's remove these stars and put, for example, a sphere. So if I press here, yeah, now you have this box, and we will change the length of the box just to do the standard checkerboard that I like. Look, I will now change the base color with a procedural pattern. Here is pattern. Okay. Here is my pattern. And let's add some movement here. Not correct. Oh, I know it is not correct. Yeah. We can combine them using the combine functions. You have to use these operators here, these Boolean operators here. This is the normal one, the Boolean one, and this operator will combine not only the shape but all the other parameters. Okay, so you can see that now you have here. I will, when I let me, for example, add here diminish the specular, yeah, way too bigger. Yeah. And you can of course add many more here, not just two. And when we translate, another very cool thing, when we translate or rotate, you are also translating this function here, right? If you do here, so it solves. This is one of the problems when you are doing ray marshing, because when you are moving the object, you have to make sure that you have also moved the texture, okay? Because otherwise the object would move, but the texture would be left behind. So like I put this texture here, I can also, for example, apply one. Let me see how does this work. You can see some small details here. And yeah, we will not use all this complexity. We can use now the standard Boolean operations like smooth Boolean, and this is very cool, it will also blend the materials, so it blends the shape and all the properties. So now you are entering into a zone that is basically impossible to do in standard 3D programs, or at least much harder to do. You can do now something like the Terminator, where the ball goes out. Yeah, but it doesn't stop here. Let me use a scale function. I could also scale here. Let me do things properly. So this is just a scale of this previous object, but I will do it a scale before the translate. Let's scale it here, and now you have to choose multi-field SDF mode in the scale. Yeah, you can add some blend here. It's too far away. Let's move closer. Yep. But I've also implemented a cool way of smoothing. This is also new. Smooth Boolean Advanced. And what can you do with this? You can do the same blending, but modulated. Modulate the colors with a texture. Modulate the blending. So push it here. And now you have the smoothness, and you have now more parameters like shift or smooth, yeah, or contrast. See, and you can apply noise. See, magically, just happened. Try to do this in another program. You can't. So I'm pretty sure that many programs will evolve into, will take advantage of these kind of concepts. Probably some years from now we will see this kind of sign distance fields everywhere in Blender and in Blender, if I would have time, I would done some plugins to it, because Blender has some very good node-based programs, and the nodes that we are doing here could also theoretically be made in Blender, and we could change the way Blender renders, and start doing things in Blender also. But I'm pretty sure that in the future programs will also, at least partially, will have this kind of functionality to do this. So if we now, I have to align here some things because it's very messed. Yeah, this is a program with node based. It's very messed, right? Let me just stick with this. Yeah, this is. And now I can go up and down. See? Nice, right? At least I loved it. When the first time I saw it, I say, whoa. It's very cool. Yeah. Oh, see? So we have a demo now, ship it. Yeah, and of course, this is a shader. We can just go here. Oh, so now we have, by the way, look, just to warn you, now the shader is becoming very complex. And when I press, you see, it takes like half a second something to move. But I think in the next versions this will be eliminated. It will be corrected. Okay. There are many other things that you could do to create that were already available. Let me just show you some more things, some more cool things. Let's change the sphere. So this object is just a sphere, right? We will now you can manipulate the sign distance function, and for example repeat for free to the function. It's not this repeat that I would like to do. It's the normal repeat. Actually, let me think. Yeah, we have two ways. We can repeat this, and before repeating this, these properties will be applied to every one of these nodes, right? Or we can multiply here. Okay, we will do both. Repeat. Put it here. Yeah. We can have infinite spheres because they don't exist. They are just functions. So. Yeah. Mm-hmm. Yeah.
Question about extruding an object like in a sphere.
Yeah, you can deform. Yes, you can scale the. Actually, let me see. I think you have. I think there was something like that to just deform in one axis. Let me see. Transform, scale, rotate. No, actually, this one is just deform uniformly. But it's possible. Yeah, of course, it's possible to do that. More things. Instead of this simple repeat, you could also do a smooth repeat, for example. Oh, it's not this repeat. Smooth repeat. Smooth repeat. and these repetitions can blend the between the objects. See? And for example, instead of a sphere, if I did, for example, a cube. Nope, it's not a cube, it's a box, probably. Yeah, box. Not very interesting, but I can rotate it. See? And you can play with this. Now, another very interesting thing is that you can apply this rotation and smooth repeat after the object. So let me show what I mean. And so it's now showing a sphere because it's the default object. I will now, after this, do the repeat, a smooth repeat. Now using this kind of multi-field sign distance function, and after the repeat I will do a rotate. Yeah, so visually it's exactly the same thing, but it has a big difference. So the difference is that the texture that I can apply here to the cube, like for example this texture here, you see that the texture is exactly replicated into all of the cubes. Okay. Oh, the rotation must be applied before the repeats, not after the repeats. So the order is very important. Yeah. Rotate. The order where you do the operations is very important because, for example, one thing is to rotate before the repeat, where everything is rotated. Another thing is to rotate before the repetition. Okay. And there are other cool types of repetitions. One of them that I like also, it's the you can also, for example, twist the object, do a polar repetition. Let's just delete this. It's a polar smooth, but it's a smooth repetition, so you can smooth the objects. And before smooth, you can rotate the object. And you can do some very interesting shapes with it. Another thing, you can distort the object. Okay, I will show you how you can do that and a cool effect that you can do with it. So this is a cube. Instead of the cube, just use a sphere. No. Augment the sphere, and now we can, this is very polished, right? We can of course change here some parameters of of the sphere, but we want change. We want to deform the sphere. You can also do that. There are several types of the deformations. I think it's displace. Yeah, you have displace by normal, displace by direction, displace weight by normal. Basically, displace by normal, it uses the normal at each point in space to distort the object. This only makes a distortion in one direction, and this one is similar to this one, but it's like only in the direction of the normal, up and down, and this one goes in all directions. But we will use this one, and we will add some noise, and right now we can put here, and you don't see anything because we haven't displaced. Let's put it like this. We haven't do this. When I slide this, something will happen. And you have here, you can here see a bug because it's an optimization. I use to, because we are distorting the sign distance function, it no longer is a perfect sign distance function. It has distortions. So I bound the object to optimize. This kind of optimizations is something that you can spend time doing and doing good nodes that do it well. If you do every time you want to do a shader, you have to do that, you will not do that. So this way you can reuse, you spend time doing good nodes and then reuse that nodes to do cool things. Yeah, exactly. So until a certain point, I will not distort the sign distance field, and inside it I distort. But you can remove this bound a lot, so it doesn't do. So it's a lot more cooler now. And of course you can again change this. This is just a sphere again. You can do more bump. Another thing, you have correction because if I do this, it becomes flickering. So you can add some corrections here. Whoa. Okay, that's nice. I was not expecting this. That's another thing. You don't have to think. You can just put nodes and play with them. That's what I love. That's better than many demos I have seen. Yeah, very cool. So this is a correction. Basically, we are stepping slower if we slide this. Okay. And let's, for example, put the object a little smaller, increase the bound, and repeat. Do, for example, a repetition, smooth repeat. Whoa, now it's like a C. Okay. So it's becoming slower and slower, yeah. So again, it doesn't scale because we are doing a we are generating a very complex function, right? So smooth between. No. This does not use that initial cube that I was talking about. No. This is just a flat. Is like is just a 2D image, and we are. You put music now. Yeah. So that's a nice question. How do I pass this to Unity? So this shader, you can export the shader, and you can use the shader in Unity. I have never done that. I only have exported into, but it doesn't become. You are not baking into polygons. You could bake the fixed image, not an animated one, of course, into polygons. Okay, because you can use algorithms to transform this into polygons. Many programs also use that. And after that, you could import it and render it in the different program. Yeah, this is always a shader, but we could do an exporter, something that would transform this, not a dynamic one, of course, but a fixed one, something that would export this into polygons. Okay, it will have a very high polygon count, but it was possible. Yes, true. Yeah. Yeah. Yeah, you can group all this. You can select lots of group. For example, I have sphere and this place. I can go here and press Ctrl G, and it creates a group. You can output some of, for example, the displacement and call it displace. I did that before. Press here, and now you have. Wait. Yeah. I will press Ctrl W and edit. I will just go here. Wait. Ctrl C, Ctrl, yeah, into object. Yeah, you can also do that. Yeah, so the developer is saying here in the chat that you cannot export. You cannot export if you don't use the material node, and we don't have a material node for this advanced remarching stuff yet. So, but it can be probably be done in the future. Let's. How much time do I have? -30. Oh, there were some cool things I would like to show. You can do fractals here. Let me just do two things. Okay. Can I have 10 more minutes? Yeah. 10 more minutes. So I will show you two things. The one is to make fractals using this. Again, because of the nature of the program, a fractal is just a generic node, and everything will be generic. And I will show you a path tracing node. Okay. So let me remove this and this and this. You can, by the way, do this, but it doesn't scale very well, but it's okay. So now I will do just for examples here. Yeah, why it's moving. Oh, it's moving because I'm doing this translation here. I don't want it to move anymore. Yeah. And okay. I have to reset up some things here. Probably I will not start from scratch. I will reuse just the checkerboard. and instead of this boolean advanced I will just use a normal one. Yeah, so there are some bugs if when you are zoomed out, when you pick it doesn't pick correctly, but if you do the 1-to-1 ratio it works okay. So normal boolean here. Again, you can have, let me just import a nicer HDR image. It takes some time to load. It's not showing anything because I haven't objects. Yeah. Translate. One. Yeah. Much better. And now we will do fractals. So how do we do fractals? We will do fractals using a fractal node. Okay, this will be our base material. Just use for, you can be, for example, a torus, can be anything, right? For example, we will make fractals using a torus as a base. And now we can do a drag here, say that we want to do a fractal. And now this works like this. It will, for example, combine several iterations, this number of iterations, and for each iteration it will draw it will transform the object and in the way we specify here, and we'll combine everything in the loop. Basically, that's how it works. So for starting, you need a special node, which is the axis node. Okay, which basically is like an input. We are not specifying the transformation function. We can now do a translate, and if we translate, he's doing this times, okay? Doing this time, and so far it's just replicating, nothing very interesting, right? Let's just diminish here you can also look down, and the middle mouse button, by the way, you can drag using the middle mouse button, but you can also rotate. Okay, of course. See, because you are applying the let me put, for example, 8. Yeah, and it's you can combine this. We are combining using the min function, but you can use a custom function, and the custom function is also defined here. So you can say that I want to use smooth to combine my objects. And now you are rotating and creating. But this is not yet fractals. You haven't seen fractals yet. So now we will apply something that will clone somebody's just measure my temperature. I don't know why. This is getting very hot. And so one node that creates replicas of this is the axis symmetry. We will create symmetries, and we will apply the symmetries here, and now everything is multiplied. And of course we can change it. And the way it's combined, this is the symmetry could also be smooth. So I will use an X smooth symmetry. And we can smooth the object. Let's make it translate. Create a smaller one. So again, this is just torus. We are making a see? Very beautiful. You can do lots of type of, and because now we are using this MFSDF, we can, instead of using, this is just a torus, right? We can do a complex shape here with lots of colors that combine the shape in a fractal. I will show that now. For example, we are just using this, right? Now I will also create a different shape. For example, white, and it could be like a box, for example. Yeah. And we will probably have to small the box, make smaller boxes. Yeah, so you can see lots of cool stuff already happening. And let me see. Okay, I want to, the radius here, I want to combine these two objects now with a smooth boolean and use that here. And something just completely broken. I don't know exactly why, but let me try to see why. Probably something is just too big. Yeah, so okay. This is the object that I created. It's just a small box here in a very, very large torus, so we will just scale it so it can be more uniform. You barely see it, but I'm seeing it. And now we will drag here into our SDF. Nope, I did something wrong. Okay, this is here. Smooth union. And here. See, now you have two colors because are the two objects, and they can also combine. See? All the parameters are also, for example, if it's bright, if it's not bright, you can individually manipulate that. Yeah, not. Yeah. Change here and symmetry. Okay. I'm changing the smoothness. Oh. all this can be animated, of course. Yeah. So this is brand new, right? I implemented this a few hours ago. It's actually the first time I'm actually looking at these effects. And yeah, this was what I was trying to show you about fractals, how you can do fractals and use these multi-field sign distance functions to do fractals. Now I want to show you a different node. If I have 5 more minutes, I will show now the path tracing. You can now do path tracing also. So we will delete everything. I have also you can save your own. Let me just. For example, this checkerboard is just a group that I've saved. You can do your own nodes, clicking in the node that you want to save, and add selected node to library, and you can create your own library with your own things. Okay, so I just created this very basic one that is a checkerboard, so I don't have to always make one. And here is a checkerboard. So this is a render. We will now use a different render. We will use now this one, ray marching multi-field SDF path tracing, and it's almost the same, right? But it's completely different. It's actually, the code is simpler, believe it or not. This node is simpler, it implements much more stuff. But because it's path tracing, you don't have to manually generate shadows and stuff like that. It magically, everything works in path tracing. So if I just do this, you won't see anything. And why don't you see anything? Because this is more real now. You need light, right? So how do we add light? Everything is very generic here, so light is just another object. You add an object maker here, and this object has emission. So I will add here emission at 10. And here is the object. It's very basic, it's just a ball, right? But if we combine the two, it's a boolean. See, we're starting to see those kind of noisy images. We can specify many other things here, like if this is the number of samples. He's basically doing random and throwing random rays to calculate how light disperses over the scene. If we increase here the number of samples, for example, to this one, it is much more clean, right? But what all the programs do, if you know them, it will slowly converge into an image, right? If you want to use time, you can't do that. But if you just want to generate an image, you can convert. This is something lacking now. We can do that, but it's not perfect. I will show you that in a moment. How you can convert. Now, first let's play a bit with this. All right. Let's, for example, do a translate and move the light. What do you think it will happen? Yeah. It's a light. We can add a different object. Let's do some MFSDF object maker. use a boolean again. Como? Yeah, the path tracing is also a function. It's just you can export this into shadertoy. Yeah, it's just a normal function. The translate is to everything. This was okay. No, I want to translate just this one, so it goes here and here and yeah. So now they are probably one and up the top of the other. Nope. Oh, it's not yet joined. Yeah. See? Oops. I will just focus this one with the lock so I can change this. So you can see that magically this shadow appears. I don't have code for shadows. Okay, the shadow appears because probabilistically the light doesn't, the rays that come out of here don't reach this, so it's physically correct. Let's remove the light. Another interesting thing, it's all these parameters work much better now. So if I put, oh, this is the light, exactly. I will not change the light. I will just change this one. You can see here the very bright spot. You can, yeah, use this. Change everything. It's more physically correct. It doesn't support everything yet. Again, this is a work in progress. I will now add a special node that will converge this image. You just need one render target. The problem here is that the program, see now you can see now this because it's fixed to a fixed resolution, but I'm trying to convince the developer to also have this automatically without doing this, and automatically in the viewport converge the image, because this is a fixed size. Summarizing happens here. It's not great, but yeah, you can change here the iterations. Also, there is a problem because we don't have much precision. That it's the disadvantage of using this version of Godot. Godot have a very low, uses just 16 bits floats, and we need more than that. We need 32-bit floats to to have a good conversion. So if we increase here the number of iterations, after some times we will see some bending here. Okay. Another thing that this light is just to let's remove the light from here. Yeah. More? Yeah, you can add more lights. A nice question. More lights will generate a brighter image, right? How can we add more lights? We can, for example, repeat the object. The light is a sign distance function also, so you can repeat that light. So or for example, watch this. This is cool. Let's add a torus. Now our light is a torus, and we will now move the light. Yeah, of course. No,
Quer
it's
alguma coisa?
no. Thanks. I don't want thanks. Let's, for example. See? Yeah. See? A light as a torus. It's very cool. And we can, of course, multiply the lights. So let's just remove this torus, add a sphere, and just repeat the object. A polar repeat. No, I don't want a polar. I want just a simple repeat. Simple repeat. Put it here. And now we have lots of lights. And we will move the lights up. Whoa. Yeah. See? Everything. And, of course, everything still works. So this sphere could be, of course, deformed, displaced, for example. Displace, let's say, by direction this time, and we will use a pattern and multiply by sine. We have now music. George is no. You haven't seen. That's bad. Yeah. No, it was okay. No, it was not this. This was the sphere of the light. I want to transform the object, right? Not this. Yeah. Add some correction. Like here. And it's a bigger amount. See? It was somewhat similar to the image I was showing here, okay? But this one, yeah, it doesn't blend with the word, but it's just changed this into a node that blends between the two. You can also add a 360 image like this one. And we'll have this way we'll have the light could be the image itself. So if the light has a sun, it will, so this now it's much brighter. Let's just remove this accumulator, put it here. So we will now have again noisy images. So we have bright lights up and also the see now it's green here because we are in a field where things are green, so automatically it reflects the green of the fields. Let me just whoa, what did I do? change the size of the sphere. And possibly add a blend here. Smooth boolean. Yeah. So you see automatically these holes are darker because light doesn't get there. Yeah. So this was the thing I was trying to show. I think you like. I hope you like it, and that's it.
Thank you, Paulo, for that. The competition has started for Material Maker, so if you want to do something with Material Maker, you can submit it. You have 1 hour to do something. Submit it to the party system. If you need a vote key, let us know. If you don't need a vote key, well, then don't let us know. But submit your entries, and in about 1 hour, we will have that compo. Meanwhile, we'll try to show some demos. Paulo, can you recap for people who showed up on the stream later and they don't know where you're supposed to get Material Maker? Can you recap that real quick?
Yeah, of course, yes. You can download Material Maker. Just search for Material Maker on Google. Well, Material Maker. Oh, no internet for some reason. But search for Material Maker and search for my plugin. That is this plugin for Paulo Falcao. Material Maker Ray Marching, and you just need to download this JSON file and add the JSON file here in Manage Libraries, Load Library, and load the JSON file, and my nodes will appear. Okay, it's just that.
Okay, thank you very much, everybody. Please give a round of applause to Paulo. Thank you for the seminar.